The first tool that we'll look at is Read Messages. On the left is the Help menu. As you can see, there are two required arguments. The port is the serial port that the M2 is connected to. If on Windows, it would be something like, for instance here, COM3. If on Linux, then possibly dev TTYX. CAN baud is the baud rate on the bus. It is likely going to be 250K baud or 500K baud, but if you're not sure, then entering 0 should attempt to do an auto baud rate detection. If we just do a basic read, you can see it will continue printing until you manually stop it with Control-C. Scrolling up and viewing the format of the message, we can see the first byte here is the priority of the message. This will be between 0 and 7, with 0 being the highest priority. The next 2 bytes is the PGN. And then we have the source address of the sending node. As you can see, mine are all 0B, which is for the brake controller that I have on my test bench. And then we have the destination address of the receiving node. Mine are all FF, meaning these are for broadcast messages. On your bus, if you have more than one ECU, you could see communication between them. Next is the length of the data in bytes. And lastly is the actual hex string data. Transport protocol is used for transmitting messages that are larger than 8 bytes long. Therefore, it will take more than one CAN packet to transmit. TruckDevil will automatically keep track of these messages when received and repacketize them into a single message, so it is easier to view. By default, the transport protocol messages will be displayed as well as the repacketized messages. But the TAC-A flag can be used to abstract the transport protocol messages, keeping only the full-length messages visible on the screen, as you can see here. I did not specify this flag in this instance, meaning all of the transport protocol messages will also be displayed. These are the ones with the parameter group of hex EB or EC. The flags T and N are both used for limiting the number of messages that will be read. TAC-T is for the amount of seconds to print messages for, in this case 2. If not specified, it won't be limited. TAC-N is for the number of messages to print, in this case 10. Again, if not specified, it won't be limited. TAC-L is for logging the messages to a file. It will be logged to the current directory with the form of M2, collected data, and then the time. Lastly, TAC-V is for verbose. It's for decoding the messages in real time. This will work for many of the most common J1939 messages and PGNs in use and UDS messages. As you can see, it has decoded all of these messages. So there's the original, and then the rest is the decoded version. As you can see, it has the source as the brakes, and the destination node as global, meaning broadcast message. Additionally, you can see the hex F001 PGN has been converted to decimal 61441 with the PGN label of Electronic Brake Controller 1. PGN data length of 8 and transmission rate of 100 milliseconds per second. Next, it has the list of suspect parameter numbers, or SPN, that make up the PGN, with their values decoded. If an SPN does not have a value specified, that means it had all ones in that bit position of the data, so it can be safely ignored. You can see, for instance, SPN 1121 here, EBS brake switch. That bit position had a 0, meaning the brake pedal is not being pressed currently.